Hello everyone, my name is Praveen Sanjay Pawar, and today I'm going to explain the types of flow in fluid mechanics. So let's start. Types of flow. So before knowing the types of flow, first we have to know the types of flow basically. So what is the flow in fluid mechanics? So flow is the refer the movement of fluid, maybe or it is the liquid or the gas through the various mediums or environment. This can be characterized by several factors such as the pressure, velocity, density, viscosity. The study of flow helps to understand the how fluids behave under the different condition. So types of flow. So in fluid mechanics, there is a types of flow characterized in six types. So first one is the we can see the list by one. So first one is steady and unsteady flow. So what does it mean by steady flow? Steady flow means the fluid property in which pressure, velocity, density is not changing over the time. Means fluid property cannot be changed according to the time. Example, garden house watering system means when your plants steady stream of water and uniform ensure the uniform coverage. So next is unsteady flow. Unsteady flow means what? It defined as the properties such as the pressure, velocity, density changes at over the time. It will fluid properties can be changed at any point according to the time. Example is X pipeline varying diameter manages different flow rates in industrial processes. Means so here you can see the images in gardening house system. And the second image is you can see the unsteady flow. Means here we have first one is the ultimate constant pressure ultimate source. And then it divided into three types of pipe, means varying diameter. First one is the slow, second one is the medium, and third one is the live. So in here you can see the velocity of fluid is changing. So next is the uniform and non-uniform flow. So uniform flow means what? Uniform flow is the that type of flow in which fluid velocity is the same at every point. Means whenever you check the fluid velocity at any point at any time, it will be the same. Example for that is the straight pipe water flow ensures efficient water supplies in homes. For uniform flow, dV by ds is equal to 0. So in first image you can see the there is no varying diameter of pipe. So just because of that, fluid particles flowing in the straight and with constant velocity. If you check at first point, second point, and third point, that velocity will be the same. Second type is non-uniform. Non-uniform is exactly opposite to uniform flow means fluid velocity varies from point to point in the flow fluid. Example, pipeline with varying diameter. Here in second images, you can see that it's first one at the first point velocity is different, second point is velocity different, third point is different. If you check going to check the velocity at different point just because of the diameter of pipe is varying. So because of that, for uniform flow dV by ds is not equal to 0. So third type is that laminar and turbulent flow, which is the most important flow types of flow in fluid mechanics. First is the laminar. Laminar flow means what it defined as a type of flow in which fluid particles move along the well-defined path. When fluid particles are in well-defined path and they can move streamline along with the streamline and parallel means in laminar flow. Fluid particles can be never intersect with each other because of they are parallel to each other. Example, flow of blood in flow of blood. So in image you can see that flow particles are each other to parallel to each other. They will be never intersect with each other. So this is called a laminar flow. Second one is the turbulent flow. Turbulent flow means what? It is the it is that type of flow in which fluid particles are move in zigzag way. They are not in well-defined path. They can move in zigzag way. So because of, for example, that industrial pipeline necessary for mixing and chemical reaction. So in industrial pipeline turbulent flow is used because when we want to mix two or more type of chemicals each in together, then we have to use turbulent flow just because it moves in the flow moves in zigzag way and intercity with each other. In image, you can see the turbulent flow, which is the fluid particles are not in well-defined part. They are not in parallel to each other. They are intersecting in each other. So, uh, so here I mention the small photo that is the per pipe of flow and type of flow means we can find the flow is which type of means laminar flow or turbulent flow using Reynolds equation. Reynolds equation is that rho Vt divided by mu. So how we can find the if Reynolds after the calculation Reynolds number is come less than 2000, then that flow is called a laminar flow. And if the run after calculation Reynolds number is come above the 4000, then that will be the turbulent flow. And if Reynolds number come in between 2000 and 4000, then we can call that is the transition flow. So this is about laminar and turbulent flow. Next one is that compressible and incompressible. The name itself indicates that compressible and incompressible means what? Compressible means the fluid density changes significantly within the fluid in common gases. We can't change the density of fluid. We can change only density of gases. And here I mentioned that is example gas pipeline ensures safe and efficient transport of nature. Compressible gas pipeline, or we can consider our home. We are using that the cylinder in that the gas is compressed and fitted. That next is incompressible. Fluid density remains nearly constant types of liquid. Example pipe water flow ensure consistent pressure in municipal water supplies. So here in image you can see as a liquid cannot be compressed, gas will be the gas we can compress and fit in the small objects. Fifth one is that the rotational and irrotational flow. Rotational flow is that type of flow in which fluid particles are flowing along with the streamline and rotates about their own axis. Means rotational flow means what it indicates is now in name, that is the fluid particles are rotating about their own axis and along with the streamline. Example, washing machine. Washing machine, we see the water flow is in circular motion. That means they are rotating about their own axis. So just because of effect and cleaning goes through the negation. Second one is the irrotational flow. Irrotational flow means what? If the fluid particles, while flowing along with the streamline, means in rotational flow, fluid particles moving along, flowing along with the streamline, but they do not rotating about their own axis. Example, flow of wash basin. In image, you can see the here fluids of flow and the rotational difference between that both. And the last type is that one dimensional, two dimensional, and three dimensional. Here also the name indicates what does it mean by one dimensional flow. First of all, dimensional dimensions means three axes, X, O, Y, Z. That type of color is dimensions. So one dimensional flow. The one dimensional flow means the flow parameters which change in primarily in only one direction. Maybe it is X, maybe it is Y, or maybe it is Z, but it is in only one. Example, narrow duct airflow, commonly used in HVAC systems. The second is two-dimensional flow. Two-dimensional flow means what? Flow where parameters change into the two-dimensional. So maybe it is XY, maybe it is YZ, maybe it is XZ, or any other combination except. So example, wide river flow supports diverse in ecosystem. And last type, that is the three-dimensional flow. Three-dimensional flow means what? Flow where parameters change in all three dimensions. Means this type of flow we can see in the at the river at the time of flood. So we notice that the flow of water is going in anywhere in any direction maybe it is XY. That means it is going in all three directions, not only in one direction. So this is the best example of three-dimensional flow is flow at the flow of river at the time of flood. In image of three-dimensional flow, you can see also that it is the flow is moving in X also direction, in Y also direction, and in Z also direction. So this is the short presentation about the types of flow in fluid mechanics. Thank you.